Hello and welcome. So last time I shared a video on how I use Crystal on my local development environments and how I use that to compile CLIs or compile utilities that can be run on different platforms for different purposes. And that got some questions on how I cross-compile, what are the dependencies and things like that. And I wanted to come back to I share back a link to I share a proof of concept of that a couple of months ago or maybe 6 months ago on how I use that to do self-contained executables for macOS that didn't require any dependency, and that you can build it from your Linux machine, or vice versa, that you can use Crystal on Mac to cross-compile to Linux, right? And I realized that maybe it was time for me to go back to that proof of concept and then do this video, right? Tell people, like, show it people how I did it, how I compiled different libraries, how everything was packed and how I use it, and what was the secret sauce that was behind it. And I realized that the proof of concept is gone. I couldn't find the code. I couldn't find anything on my notes. I didn't automate the process. I just built the necessary packages and used it in my different machines. And I realized that that's a terrible practice. I didn't properly document the proof of concept, which is bad. And well, for me to do this video, I need to scratch that original table of content that I wanted to talk to you, and then I want to go through and just focus on recreating that from scratch. So that's what I did early today. I rebuilt, and I took a couple of necessary libraries to do. I didn't take all the libraries that Crystal support, but just to explain you a little bit how this works. When you call Crystal build, it's going to generate the object code native for your platform, but you can indicate a couple of commands in order to generate for a different platform. And then you need the certain type of libraries in order to link to that, in order to generate an executable, okay? And that depends on each of the platforms. And what is behind of that for the linking across different platforms, without depending on a lot of compilers and things like that, I use SIG, which is a different language, but provides a cross-compiler built-in, supporting all the linking across the different platforms. And it also embeds Muscle, which is a C library that allows you to generate static executables. And that's actually what Alpine Linux does. It uses Muscle, which is a replacement for glibc, that allows you to generate static executables, as I show on my previous video. So since I was not able to find all the code to replicate this, I built something from scratch that actually grabs those packages from Alpine Linux, those different binaries for the different platforms, only the libraries that I need, right? And I'm using Ruby because that was easier. That was something of the scripts that I had at that moment. I'm going to share later, like this another proof of concept or another Scratch document, but I wanted to show you how that works quickly. Okay, so I'm always using a Docker container for that. I have Ruby here, where I have my write file that I show you to you, and I have this package task that I have here. So what is this package task is going to do is it's going to actually download the binaries of each one of those, and then it's going to generate a package file. If I do a tree here, you're going to see, like, for that platform that I selected, is collecting all the lib files that I need, right? Like libyaml, libgc, which is the garbage collector, libevent, which is the event loop, things like that, and then it's packaging into this file with a platform triplet, which is the bytes, the platform, and the C library. And then I can use that file to to copy to another platform that is not this one, or maybe it is a Linux platform but it doesn't generate a static binary. Maybe it's a glibc distribution like Ubuntu or things like that. Anyway, what I do have, I have here on a separated machine, I have a Mac running on an M1 machine, and what I have running is Crystal and SIG compilers, the latest version of both, installed on this machine. Okay, and what I'm going to do now, I'm just going to copy a demo script that I have here, which is called a simple server, which is a simple HTTP server, right, that just respond hello world, nothing weird. And I'm going to copy that simple server to that Mac Mini, and then I'm also going to copy the package file that generated that to the same place. Actually, I need to say that it's the tar file to that directory, right? Here on the Mac Mini, I'm just going to do extract that file. So now I have the directory that contains all the libs that I showed before. And what we're going to do, we're going to compile the simple server there, but targeting to Linux. So I'm just going to do crystal build cross-compile. I'm going to say the target, which is x86-64 Linux muscle, and I'm going to say simple server is the script. What is going to happen is going to oh, I forgot, since I don't have OpenSSL because I haven't figured out, I just brought it a couple of packages, I'm going to exclude that from here. So I'm going to say without OpenSSL, and I'm going to do the cross compilation again. So this is going to omit OpenSSL and only leave certain libraries. So here, when you do crystal cross compilation, it's showing you the build command or the linking command, the command that you're going to use to link your executable. So here's the object file that generated the target of the executable name, and then it's telling you all the libraries that you need to link with. So for example, you have here is the garbage collector, here's the lib event, which is for the event loop, etc., etc. So what we're going to use is we're going to use SIG CC. We're going to do the target, the same target that we did before, and what we're going to say is we're going to say take the object file that you have here and just call it simple Linux as the target object. Now, if I say link with seed library, link the library GC, and then the library event, what is going to happen is going to tell me that it's unable to find those libraries. And it makes sense because I didn't indicate where to find those libraries. So I'm going to say exactly like that, and I'm going to do it again, but here I'm going to indicate -L uppercase, which indicates a load path for the libraries, and I'm going to indicate that it's relative to this directory, and I'm going to indicate to bring the lib directory. Now what is going to happen is going to try to link to those things, and it finds a missing reference, which is the unwind library, live unwind, which is something that Crystal uses to do backtraces. Well, it's by default is included on Alpine Linux, but in this case you need to be explicit that you actually want that library to be linked. So what I'm going to do that, and what actually it generated a new file, which is simple Linux, 4 megabytes. If I do a file to simple Linux, I see that it's 64 bits, static linked with debug info, no stripped information, blah, 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 etc., etc. What I'm going to do, I'm going to copy that file back. So from that, I'm just going to do simple Linux, copy that back here. And if I just do the same thing, it's executable. If I do an LLD to see the dependencies, it's going to say not a dynamic executable because it's static linked. And if I do simple Linux, the application runs. And just to confirm, I'm just going to do a plow on that just to see if it's not breaking, having exceptions or things like that. And since it's not a release build, it's just showing 16,000 requests per second, not much, but it's running. So that's basically the concept. So I just show you like what I originally did, but it's missing parts of like how to do for macOS. And I hope that once I recreate the proof of concept, I can show you that, and potentially that's a new video. So moral of the story is always make a backup even of your proof of concept, but try to document it, which I didn't. So don't do my mistake again. Hope that you enjoy it. Certainly I did, coming back to this and potentially having this out there, release on the code and things like that is going to avoid me doing the same mistake again, which is losing time. Okay. Have a nice day and see you soon. Ciao.